So here there's Math 11. So we're just previewing, getting students ready for final exam. Again, you could look at this as a review for Math 11 to get ready for next year, Math 12 or Pre-Calc 12. So it's more for enrichment as well. Anyways, so here's the radicals, and they want you to order the following from least to greatest. I think to do that is best to write all of these as entire radicals. So to write all of these as entire radicals, this here, what you do, you square the 6, that's 36. You could put it inside here, times the 3 still. So that is, and you find out what that is, the same thing. You square the 11, which is 121, times the 7 in there. And then square the 9, put it inside, 81 times 5. And then square the 2, which is 4, times 15. This will give you 60. So here are all the answers. Now we change them from mixed radicals to entire radicals. Again, if you want to change to entire radicals, just square this, which is 36, put it inside, because the square root of 36 is 6, and so on. You square this, put inside, you square the 9s, put inside, and that's it. Now you could look at them in this format, and you would know how to order them from least to greatest. So definitely 2 root 15 is the least. And then the 108, so that's the 6 root 3, and then is the 405, so that's 9 root 5. And the last one is the 11 root 7. So this is the order right there. So this is 11 root 7. This is 9 root 5. And this is 2 root 15 right there. We'll do next question. So here's another question, basically add radicals. For us to add radicals, we could only add them if the radical, or what's inside the radical sign or the square root sign is the same. So here, because these are different, we cannot add them. However, we could maybe change this into a mixed radical and make it the same. So now, what I always want you to remember is your perfect squares: 4, 9, 16, 25, 36, 49, 64, and the list goes on. So now, these are the numbers that you want to see if 76, any of this number goes into 76. Square root of 19, that's as simple as it gets. So 3 root 19, you just rewrite it, plus 2. Now root 76, you could change it to root 4 times root 19. Okay, because root 4 times root 19 gives you root 76. Now the square root of 4 is something we know, it's 2. So since the square root of 4 is 2, then you multiply it in the 2 here, which gives you 4, and you still have root 19 right here, and the 3 root 19 right there. Now they are like terms, so you could add them. And when you add them, you only add the coefficients in front of them. So you add the 3 and the 4, which is 7, but you don't add the 19s. It just stays as 7 root 19. Okay, next question. Here's another question here, and it's basically a binomial times a monomial. So you could always work backwards. So to work backwards, what I'm trying to say by that is you distribute this into here, and you distribute it then into there. So that would equal square root of 8xy times 4y squared, or 4y squared times 8xy will give you 8 times 4 is 32 x y cubed. Now minus, and this times this will give you negative. Oops, we wrote the negative already. Will give you square root of 4 x cubed y squared. Now, what does that equal? So we have to change the 32 into square root of 16 times square root of 2. The square root of x will stay as is, and the square root of y cubed, we'll change that into root y squared times root y, minus square root of 4, we already know that's 2, and the square root of y squared, it's y. The x cubed, you have to change that into x squared times root x. Okay. So now root 16 we know. And it's 4. Also root y squared, we know it's y. So this and this, we know the square root of. But these, we don't know what the square root of them. So we keep them under 1 square root 2x y minus. What about the, so the 2y is already there, and the square root of x squared is x. So that gives me 2xy. So this we know the square root of, but this we don't know, so it stays as square root of x. And this is your final answer. You cannot do anything after that. Now let me elaborate a little bit on why did I do this. Okay, so if you square rooting a variable, let's say x to the 10, all you need to do is just say that's x to the 5. So what you're doing, if you're square rooting a variable with an exponent, all you do, just half of the exponent, which is half of the 10 is 5, and thus it becomes x to the 5 without the square root. But if you have x to the 11, then you have to change that into root x to the 10 times root x. Why? Because we know we cannot have the 11, as 11 doesn't divide by 2, and therefore you look for the x with the highest exponent that goes into 11, which is x to the 10 times root x, which gives me that, and then root x to the 10, the square root of that gives you x to the 5, and the square root of x, we cannot do it, stays as square root of x. Another example, y to the 7, you know, square root that, then definitely that you have to change that to root y to the 6 times root y, because root y to the 6 will give you y cubed, but root y you cannot, because 1 doesn't divide by 2, it has a 1 on there, as that stays like that. Just this is to elaborate, but this is your answer right there. Yeah, how about here? Here we have a radical on the bottom. So what we need to do here, we need to rationalize the denominator. To rationalize the denominator, I multiply by the same thing as here, except I have to change the sign. So that is 2 root 3. Now, whatever you do to the bottom, you do to the top. So that's 3 plus 2 root 3 as well there. Then we FOIL the top and we FOIL the bottom. With the bottom, you just take a shortcut. Instead of FOILing the whole thing, you just multiply the first term by the first term. Here you get 9. And multiply the second term by the second term, you get minus 4 root 9. The top, you have to FOIL. So 5 root 8 times 3 is 15 root 8 plus 5 root 8 times 2 root 3 is 5, or pardon me. So this times this, and then this times this, so that's 10 root 24. And then again, this times this, that's 6 root 5, and it's going to be minus. And then minus 2 root 5 times 2 root 3, that's minus 4 root 15. And then to simplify, 15 root 8, we could change it to root 4 times 2 because 4 is perfect square. And 24 also, we could change it to root 4 times root 6. Minus 6 root 5, you cannot do anything about that. And minus 4 root 15, no perfect square, it goes into 15. Over 9 minus square root of 9 is 3. 3 times 4 is 12, so you just have that. Okay. Now, that would equal, run out of space again. Square root of 4 is 2 times 15 is 30. And we still have the root 2 lingering along. And 10 square root of 4 is 2. 2 times 10 is 20 plus 20. And tagging along is root 6 minus 6 root 5 minus 4 root 15 all over negative run out of space over negative 3. If all these numbers divide by negative 3, you could do that, but they don't. So just leave it like this, or divide by a negative 1 to get rid of the negative on the bottom, but that's good enough. You cannot add any of these because they're not like terms. So this is where this stops, and we'll go to the next question. So here's more with radicals. Identify the values for each of the variables for which each radical expression is undefined. So one thing we know about radicals that we cannot square root negative numbers. We could square root 0 and any number that's greater than 0. So therefore, whatever you have under the square root there, which is 6 minus 3x, has to be greater than or equal to 0 for you to be able to square root it. That's what you basically have to do. Every time that you're doing the domain of a square root function, or you're doing the restrictions, or you're finding the where the expression is undefined, you take what's under the square root here and say it has to be greater than or equal to 0. Now, just solve that. Negative 3x, move the 6 to the other side. When you move the other side, it becomes negative 6. Divide both sides by negative 3 by negative 3, and that would cancel. You'll have x. Now, when you divide by a negative number, this inequality sign flips. X less than or equal to 2. Some of you will maybe take this and say, okay, 6 is greater than or equal, and move the negative 3x to the other side, and it becomes positive 3x. When you move it to the other side, change the sign, and then divide both sides by 3 this way, and you get 2 is greater than or equal to x, which is the same as this if you read it backwards. So either or is fine. Next one. So here's another question. Again, the same thing. You're trying to find the value for which each variable is a defined radical. So you have x squared here, and that's what your concern is. So since it's x squared, and you know that we cannot square root negative numbers, now if you put in a negative number in the x, let's say negative 1 or negative 2 or negative 4, when you square it, it becomes positive. So therefore, this will always yields a positive answer. Doesn't matter what number you use, and therefore here there are no restrictions. X is a member of all real numbers, so x could be any number since it's squared, because when you square a negative, it always gives you positive. So this is the answer for this one. Hit the like button and go ahead and subscribe. Tell others so they could benefit. Thank you for watching again. Bye-bye. Till next time.